This is the Tarm 4 from LaserWorld. I bought it about 5 years ago, around 2016. It was over £3,000 plus VAT, so what's that, like £3,600? And that was kind of a big deal back then, right? It's crazy now. I've got over 20 lasers. Most of them are over 25 watts. But back then, a 4-watt laser at nearly £4,000 was a huge deal to me. One of the difficult things about lasers is unless you know someone who is already into lasering, it's almost impossible to get your hands on one, to even just try it out, right? So I was quite limited as to which lasers I had available to me. But I got to try one of these out and I thought the scanners were pretty good, so I decided to go for it and I invested in it. I mean, I use it less now, right, because I've got other lasers. But I certainly used it for a long time. I think the Laser Duck Hunt project used it, and very early prototype of the lightning catchers. I used it plus with all my presentations and shows. So it's worked pretty well, but there's a few issues with it and a few surprises with it as well. Things that I didn't expect from a company like Tarm or LaserWorld. So I'm going to open it up, try and fix the problems, and while I'm there, I'll show you around. Before we get this open, let's just have a quick look at the rear of the laser. It's quite heavy, there's a lot of heat sink in it. So you can see the rear panel here. We've got quite a few sockets there. We'll start with this power con socket here. I don't know if you can see that, it's a bit bent. I think it was left plugged in while it was shipped, and now this panel is deformed. And over here on this side, the interlock socket, that's something that's become wobbly and dodgy. I'm going to have to look at that. Let's look at the other side. You can see here the metal shutter. Oh, by the way, you should never put gaffer tape on these. I just used it there to hold it shut while it wasn't in use. One of the threaded holes for these nuts has become stripped, and so the nuts no longer hold in. That actually happened quite early on when I got it. Quite shoddy. But let's get this shutter off. So here's the inside. So you'll notice that this whole section is actually kind of sealed, at least to dust. Because there are mirrors and optics in here, you don't really want dust getting in. Here's a quick look at the electronics. Some of the driver boards on this side. And you can see the black laser module there on the left. That's quite a nice compact module for 4 watts. Completely sealed, that's what you want to see on a laser like this. Some lasers actually have all the optics just in the open here, and that's not ideal. The laser comes out just there in the lower right and is reflected off a mirror on the lower left, and then it subsequently is reflected up into those 2 mirrors that are attached to galvanometers, and it's those galvanometers that move the beam around to wherever you want it, and they can move very, very fast, of course. See the full specs there of the laser module. Typical of a laser this size, you know, a little bit weak on the red, that's very common. You can see the issue with the interlock here, it's just not really fixed to that front panel securely at all. That's why it's become unreliable just from moving around so much. And you can see here where the metal plate is deformed. I think it's only about 1mm thick aluminium. I don't think it's really strong enough, to be honest. It's a genuine Neutrik power con socket though, so that's good. Multiple layers of PCB here. This is the top one. It looks to me like this handles most of the power. Removing this second layer of PCB to reveal underneath, yeah, who would have guessed it, it's a Raspberry Pi. I must admit I was really surprised when I first found it inside this laser. But why exactly would you need a Raspberry Pi inside a laser? If you think you know why, leave a message in the comments and I'll reveal the answer later. I've straightened it in the vise and I've also given it a light, gentle hammering, and it seems a lot better, not perfect, but I think it will do. So here are the sockets from the back panel. This is the ILDA input and output to control the laser with a laser controller. And here we have the unused DMX input and output, completely unused on this model, and this is the interlock, the safety interlock. So you plug in an emergency stop button like this into here, and in an emergency you can stop the output of the laser. Here's the status light. When this is lit, the laser is active. I've actually already fixed this board, and I've also added a modification. I'll come to that in a moment. The reason I had to fix it is because these sockets here are fixed onto the front panel. There's nothing actually holding this interlock connector. It's a standard RJ45, you know, the same as Ethernet. This board would kind of bend away from it, and if you can see, these DMX sockets have become quite loose, so it's just totally unstable. And I believe that some of the solder joints underneath have become disconnected. One thing that really surprised me, there are tracks that just go off the edge here. Like, this circuit board has just been totally sliced off here. It's really, you know, 'cause it's only a single-sided board even. Like, they couldn't have just made a new one. I mean, yeah, that's not very good. So let me talk about this little pair of blue wires here, this modification that I made. So I mentioned this interlock here. You need a safe way to shut off the laser in case it starts behaving erratically. So yeah, if I push the stop button, it breaks apart two of the contacts in this connection and disengages the lasers. You mustn't ever do an emergency stop on a laser through the mains connection for reasons I'll go into in a future video. I need to do a whole video just about interlocks and stop buttons in lasers. As well as this external interlock system, there's also an interlock in the standard ILDA connection, DB25 connection, and that is so that the laser controller you're plugging in can disengage and engage the laser only when the controller is actually operational. So the interlock signal on this standard ILDA input, this is the input, is on pins, I believe it's 4 and 17 if I remember correctly. So those two pins need to be connected in the laser controller in order for laser output to be enabled, and that's the standard. So I was very surprised to find that this actually wasn't implemented on this. There is a way to implement it yourself though, if you find the wires, if you find the connections for pins 4 and 17, and then you can route that in series with the other interlock, the external interlock, and that's a way to bring up your laser into ILDA compliance if it isn't already. But yeah, like I said, I was quite surprised. European laser, I wouldn't expect those kind of corners to be cut. Another really horrible thing is here. So you can see that this is the status light. It's lit when the laser is active, when the interlock is engaged. There's also one of these on the front of the laser, but I don't know if you can see that. They've actually just hot wired onto this LED, including the resistor. And there's just a wire here that goes along here and into this LED that's in the front panel. It's one thing implementing your own hacks, but when it's done by the laser manufacturer, that's just, oh, it's just ridiculous. Thinking I'd like to replace this with a Ethercon socket, which I could do on this board. I could probably drill out the holes that I need if it avoids some tracks, and get it in here. But then I'd need to make this a round hole. I don't know what I'd do with this square heart. I mean, these DMX sockets aren't even being used, so if I could use one of those it would be fine. So I could potentially take this one off. I sort of feel like with this, although there's quite a few tracks on this board, I think I'm only using like 4. I think I'm literally using the interlock connections 1 and 2, and then the LED connections 1 and 2. So can I just make something up myself and keep this somewhere for spares, or in case anyone needs to re-implement the DMX? I'll have a look, see what I can find. Last time I ordered some PCBs, I actually got some of these RJ45 breakout boards made up. So I'm using one of those, and I've hacked on the ribbon connector and an LED, and so that should give us the functionality that I need. But it's just a test. I'll wire it up properly a bit later, but let's just test it for now and see if it works. So I plug in the interlock and the light comes on, so that's a good sign. Let's just check that it's actually enabled the laser output. Taken the resistor out of this panel mounted LED. It's designed for 12 or 24 volts, but I'm only giving it like 2 or 3, so I needed to get rid of it. You see I've put it back together pretty well. This blanking plate here out of some plastic. It's actually engraving plastic. It's all I've got. You engrave the top off and you get white writing out of it. But it's a good enough match. Put some threaded inserts there so I can bolt through this blanked hole, hold it on. And then it's also held on by these screws that are holding this front panel to the outer enclosure panel. What else do I have to do? Well, I have to drill a hole so that I can attach this little connector board. It's got the JSTs for the LEDs, and you notice there I've soldered on a threaded kind of spacer onto that, so I should just need an M3 bolt and I can screw that to the front panel. Probably put it there. Then I have to drill another hole for this indicator light. It needs to be, I think, 6 mils to fit that. Alright, let's get on with it. I'm not quite sure how to fix the threads on this. It's the shutter holder. I'm going to try using a punch to try punch around the hole, make it a bit narrower, and then I can rethread it. I've seen like proper metal workers on YouTube doing stuff like that, but I've never tried it. I'm not sure if it will be enough to fix the thread, but only one way to find out, I suppose. Well, you know what? I think that actually works. Brilliant. I've noticed that the red is slightly out, so I'm going to adjust the alignment. If you want to know more about how this works, let me know. I'll do a separate video about it. And thanks to my friend Rob at Stanwax Laser for his help with this. So here's the finished backplate. You can see I've also added a power indicator and also an 18 volts feed. That's really useful for when I'm trying to power my network laser controllers, the Ether Dreams, because they need a power input. So you're probably wondering, why is there a Raspberry Pi in this laser? Well, if you look at most lasers, they've got some kind of configuration options on the back of the laser. Things to adjust the brightness of the red, green and blue, and also the size of the output, plus also, you know, being able to flip it horizontally or vertically. Often there'll just be knobs on the back, which is my preference. Sometimes there'll be a little screen and a kind of electronic interface to it. But with this Tarm, they decided to put all of that stuff inside a web interface. So you need to connect to the laser through your network, find the IP address of the Raspberry Pi inside the laser, open a web browser, and that brings you to this interface. And you can see here you've got the power to turn the laser on or off. There's also on internal, which does nothing in this particular laser. So here we have the options to adjust the red, green and blue. We also have yellow, cyan and magenta, even though those colours don't exist in this laser. And I don't know why yellow's at 100%. Well, anyway, here we come to the next part. So let's say I want to turn the red down. It's super glitchy. Can you see that? I do that. Oh, it pops back up. Move it back up. Oh, so it jumps all over the place. It's just not what you want in a laser interface. I can't even get it back to fully 100%. Oh, I could type in 100, I suppose. Yeah, does that work? The cursor doesn't. Honestly, it's just a terribly designed system. I suppose it's quite nice that you can get the temperature, the galvo positions, the fan voltage. You know, perhaps sometimes that would be useful. I don't know. There's an advanced tab. Nowhere in the manual are these options described. So I've got, I mean, some of them. Safety shutter doesn't seem to turn the safety shutter on and off again. Maybe that's some sort of scan fail safety. I don't know. It's not explained anywhere. Timer enabled. What's that? That just seems to turn off the laser. Perhaps that's the interlock timer. Sometimes some lasers wait 10 seconds before enabling after you connect the interlock. I'm looking at the laser now. The interlock still seems to be turned off. I'll let you know if it comes back on. Well, the timer, I don't know. It's clearly not what this is because the interlock is still, the laser is still disabled even after some time. So I'm going to turn that off. No idea what it does. Scanner. Okay, so then we come to the scanner settings and we can adjust the horizontal width. You can see these controls are just jumping about all over the place. Really, truly awful. You can change the X, Y size and shift as well. You can probably tell I'm not a fan of this system. In order to use it, you need to set up an entirely separate connection to your laser. I use network controllers for the lasers as well, so it would mean I'd have to run 2 network cables to the laser just to be able to change these settings. And these are all settings that, for me personally, in my use, I never ever change. You know, I usually just set them up and forget about them. So to be able to change these from a distance is completely pointless to me. So I think this was new in 2016. And 2016 is significant because that's when LaserWorld and Tarm joined forces. I think that means that LaserWorld basically just bought Tarm out. And I suppose if I'm being charitable, this laser was quite a bit cheaper than lasers had been up to this point. They had to save money somewhere. Perhaps removing some of the controls from the back was a way of doing that, replacing it with a Raspberry Pi rather than a custom screen interface. You know, perhaps that saved money. But I am surprised that they cut some of the corners that they did. Certainly the quality of certain aspects of this is not what I'd expect from a laser with a previously very good reputation. So just for fun, let's do a quick pros and cons list for this 2016 model Tarm 4. On the pros list, good beam quality, good scanners, very silent operation, it's got temperature controlled fans, and a decent enclosure, massive heatsink. Now into the cons list. Atrocious network configuration system based on the Raspberry Pi, a blank backplate that has no labels whatsoever, and that backplate is very flimsy. There's no power light, no power switch, no fuse, no key switch. The PCB that holds the interlock socket and the DMX sockets has been sliced off at the edge, leading to an unsecured interlock socket, which led to loose connections in that interlock socket. It's got a non-standard ILDA interface because they didn't implement the interlock on pins 4 and 17. And I didn't mention in this video, but this laser seems to have a narrower output than it should do. Maybe I'll look at that in a future video. So yeah, it's a bit of a strange one. It's like half of it's really, really good. Half of it's just a bit shoddy and not what you'd really expect. And yeah, perhaps I should have contacted LaserWorld when I got it, but thinking back to 2016, I was new to owning lasers and I didn't necessarily recognise that some of those things were an issue, and certainly some of those things became apparent as I used it and of course as the laser went well out of warranty. I should say that the newer models of this laser, there's one I think there isn't a 4 watt anymore, I think there's a 3 and a 5 watt. Certainly looking at the back panel, it looks a bit better quality than the one I've got. They seem to have solved some of those issues. And there's a key switch as well, which you want to see. Do you have one of the new Tarms? Definitely let me know. I'd like to hear how you get along with it. So to sum up, you know, it's a quality laser, let down by a few shortcuts, which hopefully I've addressed in this project. If you have any questions, let me know in the comments. Thanks so much for watching. If you like this kind of thing, please consider subscribing. I'd really appreciate it. I'll see you next time.